Hello guys, this is Nihal and let us solve 6th A question of 64th Bihar PCS examination mathematics optional paper. So it says that find the intrinsic equation of the common catenary, find also its equation in Cartesian coordinate system. So let us solve this. So let us assume that this is a uniform chain and this is B, this lowest point is A and this is C. So let us assume that P be a point on this uniform chain and let us assume that this P is S distance away from A measured on the curve AP. So let us consider this AP part of uniform chain BAC. So and let us assume that WB, small wb, weight per unit of this chain, weight per unit. So what will be the total weight or gravitational force on this AP is W into S, acting at gravitational center of gravity of AP, that is WS. And at this point, T0 will act horizontally to this side, T0 tension, and at P, a tension T will act in the direction of tangent at P. So, since this AP is in equilibrium, so these forces will meet a point. This force WS will go through the intersection of T0 and T. And let us also assume that this point P, tangent at point P will make angle psi with the horizontal. So this is our system. Now let us balance since this system is in equilibrium. So let us balance horizontal and vertical forces equilibrium. So horizontal force is in this direction is T cos psi, which is and in this direction it is T0. So T0 is equal to T cos psi. Let us assume that this is equation 1. And in vertical direction, WS is acting downward and T sin psi is acting upward. So T sin C is equal to WS. This is equation 2. Let us divide equation 2 by 1. So if we divide 2 by 1, then we get tan psi is equal to WS upon T0. Now we need to make one more assumption that T0 is equal to WC. That is tension at the lowest point A is equal to weight of C length of this chain. So then tan psi will become WS upon WC. So W is cancelled. This is equal to S upon C. So S is equal to C tan psi. This is intrinsic equation of a common catenary. Guys, the second part of the question is that find also its equation in Cartesian coordinate system. What does this mean? It means that we need to find the equation in x, y coordinate system. So for that, we will start from this intrinsic equation. So at point P, tangent is dy by dx, so which is equal to tan psi. So S is equal to C, tan psi is equal to the slope of tangent at that point is equal to dy upon dx. Let us differentiate this equation 3 with respect to x. So ds upon dx is equal to c d square y upon dx square. Now we know that for small curved line, let us assume that this is ds, then this is dx and this is dy. So ds ka whole square is equal to dx ka square plus dy ka square by Pythagoras theorem for small ds. This can be uh, assumed as a right angle triangle. So ds upon dx का whole square is equal to 1 plus dy upon dx का whole square. So let us write here. So this will become under root 1 plus dy by dx का whole square is equal to c d square y upon dx square. Now we need to integrate this differential equation of second order. So we need to solve this second order differential equation, and we will get our Cartesian equation of common catenary. So let us assume that dy by dx is equal to p. So 1 plus p square is equal to c. That implies d square y upon dx square is equal to dp upon dx. So this becomes c dp upon dx. So by separating both variable dp by 1 plus p square is equal to 1 upon c dx. Integrating both sides, we get this is a sine hyperbolic inverse p is equal to x by c. So p is dy by dx. So sine hyperbolic inverse dy by dx is equal to x by c. So dy by dx is equal to, let us take this to right hand side. So sine hyperbolic x by c. Now dy is equal to sine hyperbolic x by c into dx. Let us integrate both sides. This will give us y is equal to sine hyperbolic. This will give us cos hyperbolic x by c divided by 1 by c plus a constant of integration a. Let us assume that. So y is equal to c cos hyperbolic x by c and plus a. So now we need one more assumption, that let us assume that origin is c length below the lowest point a. Here is origin. So this is length c. So at point a, x equal to 0 and y is equal to c. So in this equation, at point a, x equal to 0 and y is equal to c. So c is equal to c cos 0 upon c plus a. So this will give us c is equal to c plus a. That means a is equal to 0. So this equation become y is equal to c cos hyperbolic x by c. So this is equation of common catenary in Cartesian coordinates. Guys, we have forgotten one thing here, the constant of integration here. So let us assume that constant of integration is b. So at point A, the slope is 0. That means dy by dx is equal to 0, and at point A, x is also 0. If we assume that origin is below this point A, then x is equal to 0 and dy by dx is equal to 0. Putting these two into this equation, this gives us sine hyperbolic inverse 0 is equal to 0 by c plus b. This implies b is equal to 0. So we will get this equation and we can proceed further. Thank you guys. This is done. This is a question from statics part of the syllabus. It was an in fact easy question, and the it is asked from the even first page of the chapter itself. So you can solve you can solve this question in examination very easily. Thank you guys. You can join Telegram group. The link is mentioned in the description. Thank you.